So this is the first of two videos about solving special cases for systems of equations. This is specifically going to cover systems with no solution or infinite solutions. So the first example says solve the system, and then the second one is the same thing, but they're two different systems. So for solving, you can use any one of the three methods you've been taught. So you can either use graphing, which I don't suggest because it takes a little bit more time, substitution, or you can use elimination. Whatever seems readily easiest is the one that I would go with. So for the first example, y is equal to x minus 1 and negative x plus y is equal to 2, I would use substitution based on the way it's set up. So you're going to get negative x plus, in parentheses, x minus 1 is equal to 2. If you remove the parentheses, you get negative x plus x minus 1 is equal to 2. You'll notice the x's cancel out and you get negative 1 is equal to 2. This is a false statement. Because negative 1 does not equal negative 2, the answer would be no solution. Another thing that you could be looking out for is with elimination, you'll end up with 0 is equal to a number usually, and because in that, it's usually in standard form for elimination, all the x's and y's will cancel. So no matter how many ways you look at it, the x cancels out, and so there's nothing to solve for. Since you don't have x anymore, you can't plug it in to find y, which makes this no solution. So for the second system, again, you can use substitution, elimination, or graphing. I'm going to rewrite this in order to use elimination to show you an example for elimination. I'm going to start by subtracting negative 2x from both sides of the first equation. So you get negative 2x plus y is equal to a positive 1. And then for the second equation, I'm going to subtract 1 over so that the 2x and the y are on the same side. So you get 2x minus minus y is equal to negative 1. In this case, when you do the addition of the columns, the 2x cancels out, the y cancels out, and so does the 1, and you get 0 is equal to 0, which is true, so therefore this one would be an example of infinite solutions. You'll notice the key is that this is a false statement, negative 1 doesn't equal 2, but yet 0 does equal 0. Doesn't always have to be 0 equals to 0. Depending on the way you solve it, you may get 7 is equal to 7, or 5 is equal to 5. Anything like that would indicate still a true statement, and thus infinite solutions. So here are your u-tray. So go ahead and solve y is equal to negative 2x plus 5, and then 2x plus y is equal to 1, and y is equal to x minus 3, and x minus y is equal to 3. Okay, so again, that's trying to verify whether it has no solution or infinite solutions.